The Sun, a giant ball of plasma. It is the heart of our solar system. Life on Earth depends on it. For millennia, humans have gazed at the Sun with awe. It provides warmth, light, and energy. But the Sun also holds mysteries. Scientists strive to unravel them. Understanding the Sun is crucial. It is vital to our existence and our future. The decayist image was groundbreaking. It provided scientists with valuable data. They could now study the Sun's surface in greater detail. This will lead to a deeper understanding of solar phenomena. These phenomena can impact Earth. Solar flares and coronal mass ejections are examples. They can disrupt satellites and power grids. The decayist is a marvel of engineering. It has a 4-meter primary mirror. This makes it the largest solar telescope in the world. It is also equipped with advanced adaptive optics. These systems correct for distortions caused by Earth's atmosphere. This allows for incredibly sharp images of the Sun. The telescope's location is also significant. It sits atop the Haleakala volcano in Maui. This location offers clear skies and stable atmospheric conditions. These are ideal for solar observations. The decayist is expected to revolutionize our understanding of the Sun. It will provide data for decades to come. The Sun's surface is a dynamic environment. It is constantly changing. The decayist image captured this dynamism. It showed the swirling plasma and magnetic fields. This provided scientists with a glimpse into the Sun's inner workings. The image's clarity was remarkable. It allowed scientists to study features as small as 30 kilometers across. One of the key features visible in the image is the granulation pattern. Each granule is about the size of Texas. They are formed by the convection of plasma. Hot plasma rises from the Sun's interior. It reaches the surface and then cools. The cooled plasma then sinks back down. This process creates the mottled appearance of the Sun's surface. Understanding the granulation pattern is crucial. It helps scientists study the Sun's energy transport. The convection process carries heat from the Sun's core to its outer layers. This energy is what drives the Sun's luminosity. By studying the granulation, scientists can learn more about the Sun's internal structure. The Sun's surface is also home to other fascinating phenomena. Solar prominences are one example. These are giant arcs of plasma. They erupt from the Sun's surface. Prominences can extend thousands of kilometers into space. They are held in place by the Sun's magnetic field. Another striking feature is coronal holes. These are darker, cooler regions in the Sun's corona. The corona is the outermost layer of the Sun's atmosphere. Coronal holes appear dark because they are less dense than the surrounding plasma. They are regions where the Sun's magnetic field opens up. This allows solar wind to escape into space at high speeds. Both prominences and coronal holes are of great interest to scientists. They provide insights into the Sun's magnetic activity. This activity can have a significant impact on Earth. For example, coronal mass ejections, CMEs, can disrupt satellites and power grids. Understanding these phenomena is crucial for protecting our technology. The Sun is not just a distant star. It is the center of our solar system. Its influence on Earth is profound. The Sun's energy drives our planet's climate and weather patterns. It provides the light necessary for photosynthesis, which, as you know, is the basis of most life on Earth. Furthermore, the Sun also plays a role in Earth's magnetic field, which acts as a shield, protecting us from harmful radiation from the Sun and other cosmic sources. However, the Sun's activity can also disrupt this shield. Solar flares and coronal mass ejections, or CMEs, can cause geomagnetic storms. These storms can disrupt communications, navigation systems, and power grids. Thus, the study of the Sun is not just an academic pursuit. It has practical implications for our everyday lives. By understanding the Sun's behavior, we can better prepare for and mitigate the impacts of space weather, which is crucial for protecting our technological infrastructure and ensuring our safety. To gain a deeper understanding of the Sun, scientists have launched numerous missions. One of the most ambitious is NASA's Parker Solar Probe. Launched in 2018, it is the first spacecraft designed to touch the Sun. The mission aims to unlock the mysteries of the Sun's corona and solar wind. The Parker Solar Probe follows a unique trajectory, using Venus's gravity to slingshot itself closer and closer to the Sun. This allows the probe to withstand the extreme heat and radiation. It will eventually come within 6.1 million kilometers of the Sun's surface, closer than any spacecraft has ever gone before. The probe carries a suite of instruments. These instruments will measure the Sun's magnetic field, plasma, and energetic particles. The data collected will provide unprecedented insights into the Sun's atmosphere and the processes that drive solar wind. The Parker Solar Probe's journey is a testament to human ingenuity. The spacecraft is equipped with a heat shield made of a carbon composite. This shield can withstand temperatures up to 1,370 degrees Celsius or 2,500 degrees Fahrenheit. This protection is essential for the probe's survival. The probe's instruments are also designed to withstand the harsh environment. They are shielded and cooled to prevent damage from radiation and heat. The data collected by the instruments is beamed back to Earth, where scientists analyze it to learn more about the Sun. The Parker Solar Probe has already made groundbreaking discoveries. It has observed switchbacks in the solar wind, which are sudden reversals in the magnetic field. These observations are challenging existing theories about the Sun's atmosphere and are providing new insights into the mechanisms that drive solar wind. The Parker Solar Probe's mission is expected to last for several more years. During this time, it will continue to orbit the Sun, getting closer with each pass. The data collected by the probe will help scientists answer some of the most fundamental questions about the Sun. One of the key questions is the mystery of coronal heating. The Sun's corona is much hotter than its surface, a puzzle that has baffled scientists for decades. The Parker Solar Probe will measure the corona's temperature and density, which will help determine the mechanisms responsible for this extreme heating. Another mystery is the origin of the solar wind. This stream of charged particles constantly flows from the Sun, filling the solar system. The Parker Solar Probe will study the solar wind at its source, providing clues about its acceleration and composition. The Parker Solar Probe is just one of many missions dedicated to studying the Sun. Other missions, such as ESA's Solar Orbiter, are also providing valuable data. These missions are part of a global effort to unravel the Sun's mysteries. The future of solar exploration is bright. New telescopes and spacecraft are being developed, which will allow us to study the Sun in even greater detail. These missions will help us understand the Sun's influence on Earth and will also shed light on the behavior of other stars in the universe. The knowledge gained from these missions will not only advance our understanding of the universe, but will also have practical applications. It will help us develop new technologies for space exploration and will also help us protect our planet from the Sun's potentially harmful effects. The Sun is a star. Like all stars, it has a finite lifespan. In billions of years, the Sun will exhaust its nuclear fuel and will then go through a series of dramatic changes. It will eventually end its life as a white dwarf star. However, the Sun's influence will continue long after it is gone. The elements forged in its core will be scattered throughout space, becoming the building blocks for new stars and planets. In a sense, the Sun's legacy will live on for eternity. As we continue to explore the cosmos, the Sun remains a constant reminder of the power and beauty of the universe. It is a source of wonder, inspiration, and scientific inquiry. By studying the Sun, we are not only learning about our own star, but also about the fundamental processes that govern the cosmos.